Most people think the speed of light is just some number we measure, like measuring how tall a building is. You go out, you measure it, you write it down. But it's not like that at all. The speed of light is woven into the very fabric of how the universe works. And I'm going to try to show you why this is so strange and wonderful. Let me start with something that bothered people for a long time. If you're riding in a car going 60 miles an hour, and you throw a ball forward at 20 miles an hour, how fast is the ball going relative to the ground? Well, that's easy, 80 miles an hour. You just add them up. If you're on a train and you walk toward the front, your speed relative to the ground is the speed of the train plus your walking speed. This seems obvious. Now here's where it gets interesting. Suppose you're in a car going very fast, say half the speed of light, and you turn on your headlights. You'd think, well, the light from the headlights should be going at the speed of light plus half the speed of light, right? Because the car is already moving forward. The light should be going at 1.5 times the speed of light relative to the ground. But that's not what happens. Not at all. The light goes at exactly the speed of light, not 1.5 times, not 1.01 times, exactly the speed of light. The same speed as if the car were standing still. Now you might say, wait a minute, Feynman, that can't be right. That doesn't make any sense. And you're absolutely correct. It doesn't make sense if you think about it the ordinary way. But nature doesn't care what makes sense to us. This is how the universe actually works, and we have to accept it. This fact that the speed of light is the same for everybody, no matter how fast they're moving, this one simple fact leads to all sorts of bizarre consequences. Time slows down when you move fast. Distances shrink. Mass increases. All of these strange effects come from this one peculiar property of light. But here's what I really want to get at. Why is the speed of light what it is? Why 186,000 miles per second and not, say, 1,000,000 miles per second or 1,000 miles per second? Now let me tell you something interesting. The actual number, 186,000 or 299,792, 458 meters per second or whatever, that number doesn't mean anything by itself. It depends on what units you use. Miles, meters, furlongs per fortnight. These are all arbitrary human inventions. The universe doesn't know about miles or meters. But there's something about the speed of light that isn't arbitrary. Let me show you what I mean. The speed of light comes from Maxwell's equations, the equations that describe electricity and magnetism. When Maxwell worked out these equations in the 1860s, he found something amazing. The equations predicted that if you wiggle an electric charge, you create a wave, an electromagnetic wave, that travels through space. And when he calculated how fast this wave should go, he got a number from combining two constants, the electric constant and the magnetic constant. These are properties of empty space itself. When you multiply these two constants together in just the right way, you get the speed that electromagnetic waves travel. And guess what? It matched the measured speed of light. This is how we figured out that light is an electromagnetic wave. But here's the deep question. Why do those constants have the values they do? Why is empty space, vacuum, the way it is? And I have to tell you honestly, we don't know. We can measure these properties. We can use them to calculate all sorts of things. But we don't know why space has these particular properties and not some other properties. Now let me tell you about something even stranger. There's a number that physicists have been obsessed with for almost a century. It's called the fine structure constant. It's about 1 over 137. This number is special because it has no units. It's not meters or seconds or anything. It's just a pure number. This number tells you the strength of the electromagnetic force. It's made up of the electric charge of an electron, the speed of light, and Planck's constant all combined together. But when you combine them in just the right way, all the units cancel out, and you're left with this pure number, approximately 1 over 137. Now, why is this number what it is? Nobody knows. It's one of the greatest mysteries in physics. Paul Dirac said it was the most fundamental unsolved problem in physics. And I agree with him. You might say, well, maybe we'll figure it out someday. Maybe. But here's the thing. If this number were even slightly different, the universe would be completely different. If it were 1 over 140 instead of 1 over 137, atoms wouldn't hold together the same way. Chemistry would be different. Stars might not be able to make carbon. And if stars can't make carbon, there's no life as we know it. So we live in a universe where this number happens to be just right for life to exist. Is that a coincidence? Is it luck? Is it something deeper? I don't know. It bothers me that I don't know, but that's the truth. Let me tell you about another strange thing about the speed of light. It's not just the speed that light travels. It's the maximum speed that anything can travel. It's the speed of causality itself, the speed at which cause and effect can propagate through the universe. Why should there be a maximum speed? Think about it. If you keep pushing something, making it go faster and faster, why should there be some speed where you just can't make it go any faster no matter how hard you push? But that's what happens. As things get closer to the speed of light, they get heavier and heavier, and it takes more and more energy to speed them up. To actually reach the speed of light would take infinite energy. Only things with no mass, like light itself, can travel at this speed. This speed limit is built into the structure of space-time. It's not like a law that could be broken. It's more fundamental than that. Space and time are connected in such a way that this speed is part of how they're woven together. Now let me tell you something that confused me for years when I was learning this stuff. People say light slows down when it goes through glass or water. The speed of light in water is about 3/4 the speed in empty space. So does that mean light actually travels slower? Well, yes and no. Here's what's really happening. When light goes through a material, it's interacting with all the atoms in that material. The light wave from your source comes in at the speed of light. It jiggles the electrons in the atoms. Those jiggling electrons create their own light waves. The combination of the original wave and all these new waves from the atoms, when you add them all up, creates a wave that appears to travel slower than the speed of light. But the fundamental fields are still traveling at the speed of light. Each individual contribution moves at speed c. It's just that the combination, the effective wave, moves slower. This is one of those things that seems simple on the surface, but has a really beautiful explanation when you dig into it. Let me ask you this. If we lived in a different universe where the speed of light was different, say only 60 miles an hour like a car, what would things be like? Well, first of all, you'd see all sorts of relativistic effects in everyday life. When someone threw a baseball, you'd see it get shorter as it flew through the air. Time would slow down for moving cars. This would be normal, everyday stuff. But more than that, the whole universe would be different. The speed of light is related to the strength of the electric force and the magnetic force. Change the speed of light, and you change how charged particles interact. You change how atoms work. You change chemistry. You change stars. You change everything. The speed of light we have, this particular speed, it's part of the package deal that makes our universe what it is. Now, I want to be very clear about something. We don't have all the answers. We don't know why the universe has the properties it has. We don't know why the speed of light is connected to electromagnetism in exactly the way it is. We don't know why the fine structure constant is 1/137 and not something else. What we do know is how to calculate things, how to make predictions, how to test them. We know that special relativity works. We know that quantum electrodynamics works. It's the most precisely tested theory in all of science. We can calculate things to 10 decimal places and get the right answer. But knowing how things work and knowing why things work, those are two different questions. And the why questions, the deep why questions, we don't have good answers for those. You might ask, doesn't that bother you? Of course it bothers me. It's bothered me my whole career. But it's also what makes physics exciting. We don't have all the answers. There are deep mysteries still waiting to be solved. The speed of light is one of those things that seems like it should be simple. It's just a speed, right? But when you really look at it, really think about what it means, you find that it connects to everything. It connects electricity and magnetism. It connects space and time. It sets the strength of forces. It determines the structure of atoms. It sets limits on causality itself. And at the center of all this is a number we can't explain, a number that appears to be fine-tuned for the existence of complex chemistry and life, a number that we can measure to extraordinary precision but can't derive from any deeper principle. This is the speed of light, not just a number, but a fundamental property of the universe itself, woven into the fabric of reality in ways we're still trying to understand. And maybe someday someone sitting in an audience like this will figure out the answer to these deep questions. Maybe that someone is you, because these problems are still unsolved. The mystery remains. And that, to me, is the most exciting thing about physics. There's always more to discover, always deeper questions to ask. Thank you.